Hi, my name is Lisa Bullard. I'm the Undergraduate Director in Chemical and Biomolecular Engineering at NC State. If you're watching this video, you might be a prospective student who's still in high school, wanting to learn more about opportunities in chemical engineering and about NC State. You might be a new freshman who is looking to explore different majors and learn more about what chemical engineering might be like as a discipline. So wherever you're coming from, I hope that I can provide some information for you to help you learn more. My email address is listed here on the first slide, and I'll list it again at the end of the presentation. Feel free to reach out to me if you have questions that I can answer directly. Just to introduce myself just a bit, I love NC State. I was a student in chemical engineering at NC State and graduated in 1986. After I graduated from NC State, I got my PhD in chemical engineering at Carnegie Mellon. And after finishing that degree, I worked in the chemical industry for about 10 years at Eastman Chemical Company in Kingsport, Tennessee. I joined NC State in 2000, and so I've got about 20 years of experience in both teaching and advising undergraduates. I love what I do. I enjoy coaching and developing and teaching undergraduates. And I also have a daughter here in the bottom right corner who graduated from NC State in civil engineering. And so I have the perspective of having been a student at NC State, being a faculty member at NC State, and being a parent of a student at NC State. And here on the bottom left is a photo from a few years ago when our family, the Bullard family, was named the Wolfpack Family of the Year in 2013, which was really exciting for us. And so as my confession says, I bleed red and white, and I am happy to share with you what I know about NC State, and hopefully it will give you a little bit of a glimpse of what things might be like if you were to choose to attend NC State and major in chemical engineering. So if I were to ask you, what are the world's most pressing problems? If we were to stop and do a quiz, you might say something like, we need to reduce our dependence on petroleum as an energy source. Or you might say, we need to develop and produce vaccines to cure disease like COVID. Or you might say, we need to design products and processes that reduce damage to the environment, things that are more sustainable. Or we need to address world hunger by improving the efficiency of crop production and minimizing the use of harmful pesticides and insecticides in agriculture. I think I can make the case that each of these significant problems and more can be addressed by chemical engineers, and perhaps uniquely addressed because of the toolkit and the skills that we bring to the table. And so if these are things that are interesting to you or that you think are important, you might be able to contribute to their solution as a chemical engineer. So what makes chemical engineers different from other engineers? I think it's accurate to say that all engineers use math, physics, and their real-world experience to solve technical problems, hopefully in a safe and economical manner. But what makes chemical engineers different? We draw on chemistry and also on biology to solve a very wide range of problems. And because chemistry is such a broad field, chemical engineering is equally broad. Sometimes you see chemical engineers referred to as process engineers because we tend to focus on designing and operating and improving processes to make all different sorts of products. So when I survey my incoming students a few years ago and said, why did you choose chemical engineering? Many of them said, I liked chemistry. I had a great chemistry teacher in high school, and they really turned me on to chemistry as a field. And I like math and I'm good at it, and I wanted to do something that combined those. That was certainly the case for me. As a high school student, all I knew is I liked chemistry. I wanted to do something with chemistry, and chemical engineering seemed like a good fit. Other students responded, it seems like a flexible career with a lot of alternatives. That's very true. Some people said, I heard it had a high salary. That's true as well. Some people said, I heard it was the hardest major and I wanted to really challenge myself. I'm not sure it's the hardest major, but I agree that it is a challenging major. And for students who are looking for a challenge, it's certainly a worthy one to undertake. Other students said, I like solving problems. My high school teacher encouraged me. The job market looks pretty good, and I'm interested in pharmaceuticals. All good reasons to explore chemical engineering as a potential career path. So when I look back to graduating in the 1980s, most of my classmates who went into industry went into what I would call traditional fields, things like chemicals or petroleum or paper, textiles, maybe food processing. And so those are what I would describe as traditional chemical engineering fields. Now those are still open and very active and available to students, but since then, I would say that more and more of our students also have opportunities in what I would call expanding domain fields, things like nanotechnology, bioengineering, green engineering or sustainability, you might hear it, microelectronics, and alternative energy. And so the great thing about both the traditional and the expanding domain fields is that it really creates a very wide range of opportunity for students coming out with a chemical engineering degree. These are just a few of the many companies that chemical engineers from NC State have worked with. And if you look at some of the names, Duke Energy in the energy area, Procter & Gamble is a consumer products company. Intel is more in the electronics and microelectronics area. International Paper, the paper industry is very strong in the Southeast. The Environmental Protection Agency, Hershey, a consumer product company, the U.S. Patent Office, and so this is just a small capturing of the number of companies that hire chemical engineers. Typically in the fall and the spring, there's an engineering career fair, and sometimes we have as many as 300 plus companies who are coming to NC State just to recruit engineers. And when I do a search of those companies and say, how many of those, say 300 companies, are looking for chemical engineers, often it's in the numbers like 50 or 60 of those companies are hiring chemical engineers. And I think that reflects the strength of the job market and the diversity of the job market. One of those reasons that students tend to choose chemical engineering because of favorable job placement and job flexibility. You might be thinking, well, what exactly do chemical engineers do? Where do they work, and what does a typical day look like for them at the end of the day? And so if you want to think about it this way, if you're developing, say, a new vaccine, you have an idea for a new molecule that might provide an effective vaccine. There's a lot of research that goes on into coming up with that new product. Chemical engineers get involved in the research phase of product development and product design. At some point, when a new product has been developed, there needs to be a process that's designed to produce that product. And so when an idea moves from the research stage to the process design stage, that might involve designing the equipment to produce that product, the reactors, the separation equipment, things that are heating up the product or cooling the product, changing the pressure of the product. All of those things are things that chemical engineers would be equipped to do. When a process is designed, then someone has to manage the process of going from a design that's on paper to a real process. And here there's an image of a refinery, an oil refinery, where you've got pieces of equipment that are many feet high, very large vessels. And so you have to go from a design on paper or a design on a computer to constructing that plant. So some chemical engineers are involved in the construction of the manufacturing facility. Once that facility is built, then someone needs to make that product, whether it's a vaccine, a polymer, a fuel, or a food. And so some chemical engineers work in the area of manufacturing, and their responsibility is to make sure that the product is being produced to specifications, to acceptable quality, and to make sure that that happens consistently every day. Now, if you're making a product, presumably someone's going to buy that product. And so you need people who are focused on marketing and sales. And sometimes chemical engineers get involved in that business end of the chemical industry because they're familiar with the product, its properties, how it behaves, how it could address a customer need. And so you may not think about chemical engineers being involved in sales and marketing, but it really is a natural fit if you like working with people and you like the business end of the chemical industry. Now, once you build a process, you don't just flip a switch and it operates every day in the same manner. You're always trying to improve the process. For example, you're looking for ways to reduce the cost of the process, to reduce the amount of waste that is produced. You're trying to see, can we change the reactor conditions to improve the product yield? Or can we reduce the amount of water and electricity that's used? And so that gets into the area of process improvement. And chemical engineers are also involved in that activity. So I hope you've seen over the last few slides, we can start with an idea in a research lab, design a process to make that product, operate the process, and then continue to improve the process. And chemical engineers are involved at every stage of from concept to reality to improvement. Now, I mentioned one reason why some students choose chemical engineering is because of the starting salary. And for many years now, chemical engineering has been one of the highest starting salaries of any major on campus. And this is the most recent salary numbers. The salary is very attractive. It's not a reason to pursue a major that you don't like or that doesn't interest you, but it is a nice reward for pursuing a major that's challenging and also one that contributes to important problems. So within chemical engineering at NC State, there are opportunities to focus on certain areas of technical interest. So probably half of our students do a general chemical engineering degree, and the other half of the students might choose one of the concentrations within chemical engineering. The concentrations provide an opportunity to focus your technical electives, your chemistry electives, and your labs in a certain area of technical interest, just to get a sense for whether it's something that you enjoy, that you think you might want to work in that industry, or perhaps go to graduate school in that area. And the concentrations are biomolecular engineering, biomanufacturing, nanoscience, sustainable engineering, energy and the environment, and we also have a departmental honors program. You don't have to choose a concentration. You don't have to choose it immediately when you join the department, but it's an opportunity for students who might have an interest in one of these areas in order to explore it in a little bit more depth. In addition to the concentrations, which are typically either the same number of hours or maybe 1 or 2 credits above the general chemical engineering curriculum, there are also opportunities to pursue double majors or choose a minor. Probably the most typical double major is one of our largest is paper science and engineering. We have an awesome paper science department here at NC State, and many of their students choose to do a double major paper science and chemical engineering. We also have a great textile chemistry and textile engineering department, so that's another double major to consider. Chemistry is a potential double major. Again, all of those first three majors that I mentioned have a lot of overlapping classes with chemical engineering, so it's a natural fit. In terms of minors, there's a long list of minors that allow you to enhance your undergraduate curriculum by taking a couple of extra courses in an area of interest. Some of those courses might double count with chemical engineering, or they might not, but typically it would be 5 or 6 extra courses that you can take to explore an area of interest. For example, you might want to do a minor in math or in Spanish, in entrepreneurship, in food science, in material science. There's really no end to the number of minors that you could consider. And again, it's just a nice way to enhance your undergraduate degree to explore an interest that you might have. In terms of department size, our department is sort of middle-sized as engineering departments go. We typically graduate for the last several years around 150 graduates each year. Mechanical engineering is one of the larger departments with 300 plus students graduating. We also have smaller departments like textile engineering, paper science, nuclear engineering, and so I'd say we're sort of middle-sized as the size of departments go in NC State. We have a student chapter of our professional society, the American Institute of Chemical Engineers, which traditionally has been recognized as a nationally outstanding chapter, and they do a great job of helping students learn more about chemical engineering as a discipline by bringing in professionals from industry to sponsor dinners and talk about, what do chemical engineers do at Merck? What do they do at Exxon? What do they do at Hershey? We also have a wealth of opportunities for students to get practical experience through either a co-op, which is alternating going to school and working full-time for 3 work terms. Essentially, you graduate 1 year later, but you graduate with a year's worth of work experience, which is really valuable. Students also may choose to pursue summer internships, either with the same company or with different companies. And we have a great career development center that helps students find those opportunities and connect with the potential employers. The Engineering Career Fair in the fall and the spring is also another good opportunity for students to identify potential internships or co-ops. Here is a picture of our building, Engineering Building 1. We're located on Centennial Campus. We moved in this building in 2004, so it's a very new building. Everything in the building is very new and fresh. We have great technology in our classrooms. We have a beautiful space for students to work and to study. You may be wondering, how far is this from the main campus, and is it hard to get from one campus to another? Well, luckily we have a great bus system which is free to students called the Wolf Line, and it stops about every 7 minutes, making a loop from Centennial Campus to main campus. So it's really not very difficult at all to go back and forth from main campus to Centennial Campus, and typically you can make a course that has a 30-minute gap in going from Engineering Building 1 to the main campus. Here's an example of one of our classrooms. You can see that this particular classroom has tables with, plug-ins where students can plug in their laptops or devices. There's a built-in projector and computer in all of our classrooms. We can actually record all of our lectures, which is really handy to be able to post on the course website so that if you were to miss class, the course is recorded and posted so that you can catch up with that material. I mentioned that we have 150 students in chemical engineering, and you may be wondering, are all your classes of 150? Well, actually, we usually try to offer 2 or 3 sections of all of our core courses so that instead of being in a class of 150, you might be in a class of 50 or 75 or less. We also offer almost all of our classes in both fall and spring, which can be helpful if, for example, you're doing a co-op and you might be working in the fall and then come back in the spring and need to catch up with that course that you missed. We have over 25 faculty in the department who have undergraduates working in their labs. And so if you're thinking about, I might like research, but I'm not really sure, there's a lot of opportunities to do undergraduate research, both in the chemical engineering department and also in other related departments like environmental engineering, food science, biomedical engineering. And so this is certainly something to consider if you're thinking about, say, going to graduate school or working in research, is getting some experience in a lab to see whether that's something that you would enjoy. I mentioned AICHE, which is our professional society. We also have other student organizations that are available for professional development. We have honor societies. We have some organizations which are specific to certain industries, like the International Society for Pharmaceutical Engineering. And so whichever department you end up in, I encourage you to connect with those professional societies because they're a great way to meet other people in your discipline or other people who might have common interest, as well as learn more about, what engineers might do and what opportunities are available for you. So the bottom line is that I think our department is a great place to gain a solid foundation. Having taught here for 20 years, I've really enjoyed watching students come through our department and then staying in touch with them after graduation and following their careers. Here you can see the class picture of the class of 2019 wearing their beautiful red robes around the seal in Talley Student Center just prior to graduation. And so I hope that this short presentation has answered some of your questions about what chemical engineering is like, what NC State is like, and what it would be like to be a student in our department. If you have any other questions, I would love for you to email me at lisa_bullard@ncsu.edu. Thanks for watching and have a great day.